Guys, it's me ActiveXSploit back again with a new video on the malware development series. And in today's video, we are going to be having a look at how we can execute shellcode using uh, specific Windows API functions. And in the previous videos, we had a look at how we can how we can create a reverse shell using some basic socket programming. Okay, and in today's video, things are going to get a bit more advanced and, of course, a bit more fun. I'll actually say it's easy. It's not tough once you get the main concept. Uh, and don't worry, I'll actually explain you everything which we are going to program in today's video and what we are going to work at. So, if you haven't really subscribed yet, please make sure to subscribe to the channel and don't forget to leave a like on this video. So, with that being said, let's get started. Alright, so first of all, before moving to the practical part, let's have a look at the main concepts of how we are going to perform this today. So, first of all, we start out by storing the shellcode in an array in the same file. So, it actually can be anything. You can also retrieve the shellcode from the C2 server, or what you can do is you can simply create a dropper file which drops the shellcode to disk. It saves the shellcode in a file on the disk, which is of course a bit noisy, and antivirus engines can easily detect it. Okay, but yeah, you can actually choose any of the ways to store your shellcode. But for today's video, what we'll do is we'll simply create an array in the same file, and we'll simply declare our shellcode over there. After declaring the shellcode, what we are going to do is we simply allocate some memory in the process address space. So it's basically we allocate some bytes in the process where later on we'll actually move the shellcode to that specific memory block which we allocated. And the memory allocation is done using virtual alloc function. Okay, if you actually still don't understand what I am talking about, you could always visit the Microsoft documentation and read the syntax of the function and some description on it. Okay, so we use the virtual alloc function to allocate memory in the process address space, which is basically nothing but some blank bytes, some bytes in the process, and then we use the rtail move memory function to actually move the shellcode to the allocated memory buffer in the program, okay, in the process. So rtail move memory, what it does is it basically copies a source memory block to a destination memory block. Okay, so as I mentioned over here, it says we are going to use this for moving the shellcode to the allocated memory buffer, which was allocated by the virtual alloc function in the process later, or in the program later. Okay, and then we simply use the create thread function, which basically creates a thread and it starts executing certain piece of code. So for the malicious purposes, what we are going to be doing is uh, we simply use this function to create a thread which basically starts executing our shellcode. Now I know that this sounds confusing, and it is a bit complex, but don't worry. When we get to the programming part, everything should make sense. And also, I'll mention some links in the description for you to read the documentation. And so with that being said, let's get to the practical part. Alright, so I have my Windows development VM up over here where I'll be actually working, and if you wonder what I have as my configuration, which is what compiler do I use the standard Visual Studio 2019 build tools. So you can also install it, or you can use the compiler which you want. So first of all, we'll start out by simply declaring the header files which we need. Okay, so we'll include the uh, windows.h header file, which is the header file for Windows API. So I could actually leave a comment over here saying header file for Windows API. And we also need the standard input output library. Oops. And now what we do is we simply create a main function. So I'll just say int main, And now what we can do is we can simply we can actually create an array over here saying char shellcode. And what I'll do is I'll actually leave this array empty for now. I'll actually put the shellcode at the end, and I'll also create another integer type variable which is basically going to hold the size of the shellcode. Okay, so we'll just say int size, or we could say shellcode underscore size equals to size of shellcode. Okay. Now what we can do is we can simply we can actually create a pvoid type pointer. Okay, we basically create a pointer saying pvoid, or wait, it's actually void and not pvoid, I believe. Yep, it's void. Sorry for that. We can say void exec mem, which is basically going to be the executable memory part, which is the allocated memory. So we'll just leave a comment over here saying allocated memory. So the execmem pointer over here, it's basically going to be the memory address where we are going to move the shellcode to, and we'll simply create a thread pointing to that particular memory address, which is basically going to execute the shellcode. Okay. Now what we can do is we could simply call the virtual alloc function execmem equals to virtual alloc. Now, if we actually talk about the arguments passed to the virtual alloc function, the first argument which you see over here is LP address. Okay, so this basically means that you have to assign the memory address where you want to uh, uh, allocate a buffer. Okay, where you basically have to allocate memory region. Okay, uh, but in our case, we don't know the memory address. Okay, so what we do is we simply set this parameter to null. And once we set this to null, what happens is that the system determines the location where to actually, allocate some memory. Uh, then we have the DW size parameter, which basically means the size of the memory region, the size of the allocated buffer. Okay, how much size we actually want to allocate. So we are basically going to allocate the size which is same of the shellcode. Okay, so we will simply pass the shellcode underscore size variable up over here. And then we have the allocation type parameter and the protection type, the FL protect type parameter. Okay, sorry, argument. Now, FL allocation type means what kind of allocation you want to give that to the particular memory region. Okay, the memory buffer. So what we are going to be doing is we'll just assign the mem commit and mem reserve allocation types. And then we have the protection type, which is FL protect. And in this, you have to basically assign page execute read write, which basically means that you are assigning this specific memory block read write and execute privileges, so that your shellcode can then execute later on. Okay, so I'll actually leave up a comment over here saying allocate memory in a specific region. And then we use the rtail move memory function. So rtail move memory, and rtail move memory is very much simple. So first parameter which it takes is the destination where we want to move something. Okay, where we want to copy some sort of data, where we want to copy a specific memory block. So we'll just say execmem, which is basically going to be our destination. And then we have the source. So now for source, what you provide is you basically provide the thing which you want to copy. So we want to copy the shellcode over here. So what we'll do is we'll just say shellcode. We'll pass the shellcode array over here, and then we have the length. So we basically specify how much you know how much length do we want to copy to the destination, how much size do we need. So for that, what I'll do is I'll simply say I'll simply pass the shellcode size parameter over here. Okay, And I'll also leave up a comment saying move the shellcode to the allocated memory region. And then we simply use the create thread function to actually create a thread which basically points to the newly created memory buffer, and it basically creates a thread to execute that specific shellcode. So we simply say create thread. And if you actually look up for create thread function, you'll see that we have a lot of arguments over here. So if you have a look at them, first of all, we have the uh, LP thread attributes argument. So this basically means that you basically pass a pointer to the security attribute structure, but we currently don't need it, so we'll just set this to null. And then you have the DW stack size parameter. So this is basically over here, what you do is you basically specify the size of the stack. Uh, but we simply set this to 0. And once you set this to 0, what it actually means is that the executable, okay, uh, it basically takes, the system basically takes the size of the executable as the size of the stack, okay. And then we simply say we simply point to the memory location where we actually want to start a thread and execute that the code inside the thread, sorry, execute the code inside that specific memory region. So we'll just say lp thread start routine, and we simply put up exec mem. Over here we simply point to the exec mem variable. And then we have the LP void LP parameter argument, which basically has to be set to null. So I'll just set this to null. And then we have the creation flags. Creation flags means that if you simply set this to 0, the thread will immediately start. Okay, so the thread immediately starts if you set this to 0. And then we have the LP dot LP thread ID argument. So we'll also set this to 0, or we could simply set this to null, and that's also it's done. Now what we can do is we'll just say I'll leave a comment over here saying create a thread and execute code points to the memory location created using the virtual alloc function. And then we simply sleep for like 1000 milliseconds, which is basically 1 second before creating the thread. So I'll just say sleep for some time, or we could say some seconds, and then we simply say return 0. Okay, now that's all. This is completely done except the part that we have to add the shellcode. So to generate the shellcode, we could actually use MSF Venom. So what I'll do is I'll simply switch to my Linux machine over here, and I'll quickly generate the shellcode. And now what we do is we'll simply use MSF Venom to actually generate our shellcode. So I'll simply say MSF Venom, and the payload which we want to use is we'll actually use a simple calc payload, which basically pops up calc, or let's say we can actually use a simple notepad popping shellcode, okay, so which basically pops up notepad. So we'll just say dash p windows x64. Now, also I wanted to mention that if you are on a 32-bit architecture, okay, I mean if you are compiling um, if you are compiling the source code with a 32-bit compiler, please know that you'll actually have to use the shellcode, which is basically of x86 architecture. So as I'll be compiling my final program in a 64-bit compiler, okay, using a 64-bit compiler, I'll use 64 over here, okay. I'll use the 64-bit shellcode. And if you are using a 32-bit compiler to compile your shellcode, what you do is you simply use the 32-bit version of your shellcode. So I'll just say Windows x64 exec, and I'll just say cmd equals to notepad.exe. I'll specify the format, which is basically going to be C, and I'll simply press enter, and you should soon see the shellcode popping up over here. And there we go. As you can see, we have the final shellcode, and you see that the payload size is 279 bytes. So we can simply copy this up over here, only the shellcode part. And what we'll do is we'll simply switch to our Windows VM, and I'll actually make this full screen. And now what we do is we simply put the shellcode over here. So we'll just paste this off over here, and we'll make this a bit clean. And now as you can see, we have the shellcode over here and we have everything ready. So what I'll do is I'll simply go back to my command prompt, where I'll be compiling my final program, and I'll just use the standard CL compiler. I'll just say cl.exe/tc exec shellcode.cpp, and now we'll simply execute this and we'll see what happens. As you can see, we popped off a simple notepad window over here. Now, if you want to use a reverse shell, what we could do is we can simply say msfvenom/p windows x64. We could say shell reverse tcp, and we can simply provide the LOs. I'll say 127.0.0.1, L port equals to 8081, and I'll simply specify the format, which is going to be C, and you'll see that we have a shellcode which basically executes and gives us a basic reverse shell. So you can simply generate multiple types of shellcode over here. So I'll just go back to my Windows VM. Now the programming part is done. If we actually want to check what happens in the memory, okay, what exactly is happening, we can actually use a debugger to analyze this. So first of all, what I want to do is I want to print out the memory regions of the allocated buffer, okay, which is the exec mem buffer, and I also want to get the memory address of the shellcode array over here. Okay, so now what I'll do is I'll simply say printf. I'll say something like memory address of exec mem region. I'll just say percentage 0x, and I'll add a percentage p over here, which basically displays the memory address of a specified region. So of a specified pointer. Okay, so I'll just say exec underscore mem, and I'll put up a new line character over here, and I'll also add get char over here, which basically stops our program, and it only resumes once we press enter. And then we also want to print out the address of the shellcode array over here. So we'll just say printf shellcode variable address 0x percentage p. Whoops. Okay, I'll just say shellcode, and I'll change this to a pointer. So this should be fine. And now what I'll do is I'll simply compile my program over here. And once we compile it, as you can see, we have compiled it successfully. We have no errors. I'll actually start my x64 debugger. So I'll just say x64 dbg. And what I'll do is I'll actually test if this works or not. And I'll just press enter. And for some reason it stopped working. Let me actually check it. What happened? What happened? Do we have anything wrong? I believe I should not put the star over here. I'm sorry. Yep, it is completely wrong. Let me actually compile this once again. Sorry for that. And I'll execute this, and there we go. So as you can see, Notepad is successfully executing. And if you notice the terminal window, okay, you will see that you have random some sort of characters over here, you have some bytes over here. So these bytes are basically nothing but the memory regions, okay, the memory addresses of the shellcode. The first one over here is the memory address of the shellcode variable up over here. Okay, so this is the memory region where our shellcode is basically stored, and this is the memory region uh, 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 where we have the allocated, buffer, which we allocate using the virtual alloc function. So what I'll do is I'll actually start this once again, and now I'll simply attach. I'll actually switch this to dark mode. I really don't like light mode like the other people. So I'll just say appearance, or maybe not appearance. I'll just go to um, options if I can. Preferences. Nope. I'll just go to view or debug. Nope. 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 Uh, how can I set dark mode in this? I forgot the option for that. Um, mm, okay. Anyways, we'll just work with the light mode. So now, once I press Alt plus A on my keyboard, or if you just simply click on File, and if you just click on Attach over here, you'll find the PID of the malicious program, which is exec shellcode in our case. So I'll just simply attach this, and you see that we have basically attached this to a debugger, okay? And you see that the program is currently paused as we have the breakpoint, okay? It's the attach breakpoint by default. If we press run, okay, if we press this arrow icon over here, it basically goes, you know, in the running mode. It basically starts executing. Now, if we inspect the shellcode array region, we'll find that we have our shellcode stored over there. So if I actually just increase the hex dump over here, as you can see, we have the shellcode bytes stored in the shellcode array over here. So if you compare these bytes, you have FC4883. If you just go back, you'll notice that we have FC4883, and you also notice a weird string over here saying notepad. Okay, it's not notepad, but yep, it is not. Yep, here it is, notepad.exe. So this is basically the shellcode variable array. Okay, now if we actually want to inspect the memory region which we allocated, we could simply copy the memory address over here, and we could just go to our hex dump window. And okay, I forgot to mention, if you want to view a specific memory region, okay, if you want to view that, you could simply press Control plus G on your keyboard, or you could just right click over here, and you could just simply go you could just go to this go to option over here, and you could just click on expression, and we'll just put the memory address which we want to view. And as you can see, currently we do not have any sorts of uh, shellcode allocated up over here. Now once I press enter, as you can see, this executed. So let me actually add a breakpoint over here to just to analyze whether if we have shellcode in the allocated memory region or not. I actually forgot this earlier. Sorry for that. I'll just compile the program again, and once again I'll start this, and I'll just attach my process once again. I'll click on go. I'll press enter one time, and now I'll just copy the memory address of the exec memory region, and I'll just paste this off over here. And now, as you can see, we have the shellcode directly copied into our allocated memory region, which was this execmem. Okay, uh, so as you can see, this is completely working. If we simply, if we simply just go up over here and we press enter once again, you'll see that notepad executes. So, yep, this is working. Alright, so I hope you guys enjoyed the video and learned something new from it. I'm thinking of making a last video on this series on remote process injection the next time, as I also wanted to get onto some other topics on the channel. Uh, and yes, a quick announcement that soon live streams are going to start on the channel. I got my setup going on, so yep, stay tuned for that. And I hope you liked the video. Make sure to leave a like and subscribe to the channel if you are new. Goodbye and have a great day.